This is Gas Law Lecture number 9, Dalton's Law of Partial Pressures. An extension of Dalton's Law of Partial Pressures is to what we call the mole fraction. And one of the things we can say, we know that the total pressure of a mixture of gases is equal to the sum of the partial pressures. So we've gone through, if our molecules in this mixture are hitting the surface, then the partial pressure is the part of the molecules of different chemicals that are striking that surface. Very difficult value to measure, but we can determine the moles of the molecules present. And if we had a direct relationship between the two, we could determine that partial pressure. That's what Dalton's Law gives us. So think about a pie chart. If we had a pie chart and we broke out, say, air. Air is about 22% oxygen, so right around there. And the rest is nitrogen and a little bit of argon. So 22% is oxygen, about 77% is nitrogen, and the last little bit is argon plus some trace elements. Well, this is the breakdown by mole. So 22% of the moles in a quantity of air is going to be oxygen. Okay? What Dalton said is that if 22% of the moles are oxygen, then 22% of the pressure is oxygen. So if we did a little pie chart of pressure, the pressure would break out exactly the same way. 22% would be oxygen, some small sliver would be argon and trace elements, and then 77% would be nitrogen. Over here, that should be nitrogen. So the way the moles make up the mixture is exactly the way the pressure must make up the mixture. And it makes sense because the collisions of the nitrogen molecules are producing its pressure. All of the molecules are at the same volume and temperature, so they have the same energy. Okay? Well, what comes out of this is what we call the mole fraction of the gas. The mole fraction is the ratio of the moles of the gas to the total moles. We use the Greek letter chi to represent the mole fraction. So the mole fraction is the number of moles of the gas in this mixture, let's say A and B, the number of moles of A divided by the total of both A and B. And if we multiply the mole fraction by 100, we get mole percent. So we just usually leave it in this form. Now, what he showed was that the fraction of the moles must equal the fraction of the pressure. So the number of moles over the total number of moles must equal the partial pressure of the gas over the total pressure. The individual values are not equal, but the ratios are equal. Again, we call this the mole fraction, usually represented by an axis, officially chi. But if we say then the mole fraction of A is equal to the partial pressure of A over the total pressure, then we can multiply the total pressure over, and we have a way to determine the partial pressure of a gas. The partial pressure of the gas will equal its mole fraction times the total pressure. Now let's say we have a mixture of gases. Let's take a scuba tank. It's a great example. Scuba tanks can have a 3-chemical mixture, it would be nitrogen, oxygen, and helium, or they can have a 2-chemical mixture for deep dives, which would be oxygen and helium. So let's say we had a 204 atmosphere scuba tank. We take a sample of the gases. A 100-gram sample contains 9.6 grams of oxygen. We know the mixture is oxygen helium. We want to determine the partial pressure of oxygen. And from that, we'll know the partial pressure of the helium. Okay, well, we know the total pressure. So if we can figure out the mole fraction, we'll get the partial pressure, because the mole fraction times the total pressure equals the partial pressure of the gas. Well, I've got 9.6 grams of O2. We need the number of moles. So the number of moles of O2 equals 9.6 grams times 1 over 32 grams. Then the number of moles of helium is going to be equal to 9.6 from 100 is going to give me 90.4 grams times 1 mole over 4.003 grams. That will give me the total moles of oxygen and helium. So let me punch that in my calculator real quick. So this is 0.3 moles of oxygen. This is 22.6 moles of helium. So my total moles here is going to be 22.9 moles equals the total. All right, now I can calculate the partial pressure of the gas. So the partial pressure of oxygen equals the mole fraction, which is 0.30 divided by 22.9 times 204. So what's that going to give me? Punch that out. 0.3 times 2.67 atmospheres are from the oxygen. I'll just round that to 2.7. So 2.7 atmospheres is from the oxygen. So in summary, Dalton's law of partial pressures, we know the total pressure is equal to the sum of the partial pressures, but it also gives us a way to determine the partial pressures. Partial pressure of any gas is equal to the mole fraction of that gas, which is the mole percent with the 100 removed, times the total pressure.